Hello, good evening. It's 7 o'clock, but I think we'll wait for a few more minutes so that others can also join and then we'll begin today's session. Okay, so good evening once again and welcome to today's tutorial on urban services planning. Today we will discuss the content that we discussed in uh okay, one minute, let me admit someone. Admit, admit. Yeah. So today we'll discuss the content discussed in week 8, which is module 8. So mainly we discussed different methods of converting waste to energy in this week's module. So we discussed about biomethanation, which was an anaerobic method of converting waste to energy. Then we also looked into refuse derived fuel, RDF, and what is the process involved in it. We also saw incineration as a process where we heat in the presence of where we burn in the presence of oxygen. We looked into gasification also, and then finally towards the last part of this module in the last lecture we also saw how do we do a life cycle analysis and what is the importance of a life cycle analysis while when it comes to solid waste management methods that are generally used. So with that, let's try to solve some of the problems. Question 1. So again, just before we go in, let's follow the same format that we've been following all these weeks. Let's try to be more interactive. So if you can keep your video on, it would be good. If you can speak out the answers, it would be really, really good. If not, you can even put them in the chat box. so that we continue a conversation, because these are all problems, and we're trying to answer the problems together. It's not going to be like a lecture, like what we do for all the what we've been doing in all these weeks. So yeah, so with that, let's get started. Problem one: which of the following steps are executed before shredding of waste in the RDF production process? A. Air density separation. B. Sorting. C. Blending. And D. Screening. Yeah. Can someone answer this question? This is a very simple question. Yes. So Shweta says sorting. Okay. Anybody? Any other answers? Okay. Somebody says screening also. Huh. Okay. So yeah. So let's look at the. So since we have a difference of opinion, uh, let's look at that. So, in the RDF production is a screen. Okay, my slide didn't change. One sec. Sorting and screening. By looking at the words itself, we might feel it's same, but it's not actually the same. The answer is sorting. B, sorting is the correct answer. Screening is a process which comes at a much later stage in the RDF production. Why is my slide not changing? 1 minute. Yeah, slide changed. Okay, so the first two steps which involves is the first one is sorting, which is a where we use manual sorting, or we can also use mechanical separators in order to sort, which we discussed in previous week's module. We discussed about what are the mechanical methods or the machine which is usually used in order to sort. If you remember, we use different sorting methods. Then so here in this particular question, it was clearly asked that which is the step which comes before shredding or before size reduction. So shredding is the second step, which is shown over here, which is this one, and the first one is sorting. Screening is something which comes post shredding. After that, we dry it, separate it, and then we screen out what is not needed. Then we do a screening, and then we do air density separation, blending, packaging, and then storage. So when it comes to this, yeah, sorting is the correct answer for this, whereas screening comes in a much later stage. So going back, yeah, sorting is the answer for this one. Let's proceed on to the next question. Problem 2. Which of the following options currently defines the process of biomethanation? A. It is a process of aerobic decomposition of biodegradable matter in closed chamber under controlled conditions. B. It is a process of aerobic decomposition of biodegradable matter in open chamber under uncontrolled conditions. C. It is a process of anaerobic decomposition of biodegradable matter in a closed chamber under controlled conditions. And D. It is a process of anaerobic decomposition of biodegradable matter in open chamber under controlled conditions. So C, yes, I can see in the chat box, two people have answered C as the answer. Yeah, so C is the correct answer. So the keywords over here is that it is an anaerobic decomposition. So first it has to be anaerobic of biodegradable matter, because everything is given as biodegradable. We know it is biodegradable matter. Plus it should be in a closed chamber and it should have controlled conditions. So again, because this is an anaerobic, which means there's no oxygen involved. So it has to be a closed chamber. Otherwise from the atmosphere, there can be interaction with the atmospheric gases and the whole process can get disturbed. And then comes control conditions, because we need to control the temperature, the pressure, everything inside this chamber. So we are doing this under controlled conditions, and it is not under uncontrolled conditions. So yes, C is the correct answer. Let's proceed on to the next question. Yeah, so this was the explanation for that. Since you all answered it correctly, I'm not going into this. Problem 3. Which of the following is an incorrect siting criteria for incineration plants? Okay, A, B, C, D, it's put as 1, 2, 3, 4 in this. It should be in proximity to landfill sites. It should be located in vicinity of residential zones. It should be located in land marked for medium or heavy industry. It should be located in vicinity of consumers who will use steam generated from incineration plants. So they've asked about which of the following is an incorrect statement. So let's go option by option. First one, it should be in proximity to landfill sites. Is that the correct statement? Uh, yes, it can be in proximity to landfill sites. It is. it is good if it is in proximity to landfill site, because after we incinerate, the ashes or the burnt material is again brought, or the waste after incineration is again given to the landfill site. So, and the whole idea is that incineration helps in reducing the volume required in the landfill site, or it helps in more compression of the waste which is put into the landfill site. So yes, that's a correct statement. And the second one, it should be located in vicinity of residential zones. Is that a correct statement? Okay, so Shweta has already answered two, saying that that is not a correct statement. Yes, that is not a correct. So yeah, so this is not the correct answer because they've asked for incorrect. This can be a correct answer because this is an incorrect statement, because incineration, we know that we are burning waste over there, so there is a lot of pollution involved, and all that. So if you put it in the vicinity of a residential zone, it's not good. Plus, you don't store a lot of waste in for an incineration plant near the residential zone. So with all this put together, it is never put in the vicinity of a residential zone. So yes. Now, second one, it should be located in a land marked for medium or heavy industry. So that is a possible criteria, because if that's the case, then whatever is the waste from these land or medium industries can be taken into the incineration plant easily, or yeah, so there can be an interlink between these industries and incineration plant, so it can be marked, it can be located there. Fourth one, it should be located in the vicinity of consumers who will use steam engine from the incineration plant. Yes, so that is also a correct statement, because whatever energy is generated from this incineration plant can be used in order to run these industries. So there is a two-way relationship which exists. So if these are located in nearby, in the vicinity of different industries or consumers who would use this steam which is generated, it would be much easier, because otherwise when we transport this heat, there can be losses. So if it's placed very close to each other, we can make maximum use of this heat which is generated from these incineration plants. So that's also a correct statement. So which means the answer to this question is 2. It should be located in the vicinity of a residential zone is an incorrect statement. Yes, Shweta was right. Yeah, yes, due to the emission of greenhouse gases, it's not permitted. And yes, LA Raja also says that I think 300 to 500 meters was for residential zones is yeah, yeah, okay, right, correct. Okay, so let's proceed on to the next. Yeah, so this was the answer. So yes, as correctly pointed out, 300 to 500 meters from residential zones. It should not be placed very close to residential zones. Very good. Let's proceed on to the next question. Problem 4. Which of the following processes involves partial combustion of waste to energy at high temperature with a limited amount of air? So Shweta says D, gasification. Very good. That's the correct answer. So this is the definition of gasification, which says it is a process which involves partial combustion of waste to energy to generate, or waste to generate energy at high temperatures with limited, again, it's a partial combustion, so we're having limited amount of air. Let's discuss briefly about the other process also. What was pyrolysis? Can we define what pyrolysis was? It's again burning only. So it's a thermal method where we use very high temperature and then we burn the waste. So again, there are certain conditions which has to be followed, and then the outputs that we are getting out of these, for example, we get syngas out of it, which can be used for other purposes. Then we have incineration, which we discussed before, where we just burn it in the presence of oxygen. And anaerobic digestion is again biomethanation is a type of anaerobic anaerobic digestion that we are using. So yeah, so the answer to this one is gasification. So this is what we discussed in gasification. So this is the definition where we discussed that it is partial combustion at high temperature. And we also discussed the products which are coming out of it. So we have a gasifier in New Delhi, which has been set up by Terry. Right. Let's proceed on to the next question. Which of the following correctly describes deposits with reference to life cycle inventory analysis? One, resources which cannot be, let me add someone. Yeah. Resources which cannot be renewed within a limited time. Two, resources which are renewable but can be depleted. Three, resources which cannot be depleted. And four, resources which can be depleted. So yes. So Ilayaraja and Shweta says A, resources which cannot be renewed within a limited time. Very good. Yes. So deposits are resources which cannot be renewed which cannot be renewed within a limited time. It takes, for example, fossil fuels, minerals, or any other resources which doesn't renew within a given time frame or which can be exhausted easily is known as deposits. So that was deposits. What were the other things which we learned? Deposits. Then there was something called funds, and then there was something called flows. These were the three terms which we learned in life cycle analysis. So deposits we discussed. What were funds? Yeah, funds and flows. Very good. In the chat box, it's put. What were funds? Very good. Very good. Yes, very good. Yeah, so it can be depleted within time. They're renewable in nature, but it can also be depleted within time. Very good. You gave good examples also. Yes, I see in the chat box also good examples have been put. And what were flows? Very good. Few examples? Yes, very good. Yes, in the chat box also. Solar, wind, or any other yes, light, very good. So all these things which keep we will never run out of it. It'll always be there. So those are flows. Very good. So yeah, so I think all the other options will we can match to these. Like funds will be resources which can be depleted, resources which cannot be depleted. Yeah. So okay, no, more than this matches better. Resources which are renewable but can be depleted. Yeah. So let's proceed on to the next. Yeah. So these were the three different, we just discussed them. Let's proceed on to the next question. Which of the following processes does not contribute to energy generation from waste? A, anaerobic digestion, B, composting, C, pyrolysis, and D, incineration. B, composting. Yes, very good. So composting we have discussed in detail in last week's module where we discussed what are the different types of composting in landfill. How do we yeah, no, week seven. This is week 8. Yeah, week 6 we learned about composting, and then week 7 we learned about landfill. So here the question asks, yeah, so we cannot generate waste, sorry, energy from this waste in composting. In composting, we usually we can develop some fertilizers or we can use it in order for agriculture purposes, but we're not generating energy out of it. Whereas the other methods, all these three methods we discussed in this week's module, where we are talking about different methods of generating energy out of this waste. Very good. Let's proceed on to the next question. Which of the following options currently defines the process of incineration? A, it is combustion of waste at very low temperatures in the absence of oxygen. B, it is combustion of waste at very high temperatures in the presence of oxygen. And C, it is combustion of waste at very low temperatures in the presence of oxygen. And D, it is combustion of waste at very high temperatures in the absence of oxygen. So all of you says B, yeah. So the keywords is that it is in the presence of oxygen and it is at very high temperature. So that works out to option B. Combustion of waste at very high temperatures in the presence of oxygen. Very good. So B is the correct answer. Let's proceed on to the next question. Which of the following can be conducted with the application of biogas? A, electrical power generation, B, cooking, C, piped natural gas, and D, all of the above. So what can we get from biogas? Power, cooking gas, piped natural gas. D. Shweta says D. Yes, very good. So all of them can be generated. So we've discussed that these are all applications of biogas. Let's proceed on to the next question. It's not loading. 1 minute. Yeah. Which of the following is not a step in life cycle impact analysis? A. Standardization. B. Normalization. C. Characterization. And D. Weighing. Any guesses for this life cycle impact analysis? Which of the following is not a step? Guess only D. Okay, somebody says D. Fine. Uh, okay, so let's see that in detail. So life cycle in while learning life cycle analysis, this is what we learned. So we learned that in life cycle analysis, what do? We explore and evaluate the magnitude and significance of the potential environmental impact that a product or system can cause. So this is not just done in solid waste management; it's done in all aspects. Like any product or any material that we want to produce or any building that you want to build. So whatever it is, we always do a life cycle impact analysis in order to see whether uh, whatever we are developing is sustainable or not. So in this solid waste management also, because we're using certain methods, like for instance, in this module, we're discussing about different energy generation methods. So is this a sustainable method of doing, or are we creating a lot of environmental problems by generating waste out of this generating energy out of this waste? So we need to do a full life cycle analysis in order to see whether this method is a good method or how much it's impacting the environment. So in this the different aspects which includes is, first one, we select the impact category because different elements of different impacts, and for ease it's been divided into different impact categories in order to see whether it has a low income, moderate income, or a high income. And then there are certain indicators also which, for instance, if you have these many contents in it, or this much amount of methane is emitted, or this much amount of carbon is emitted out of it, then it falls under this category. So we have certain indicators which talks about that, and based on that there are characterization models. So the first method that we need to do is classification, where we select the impact categories and we classify them. And then we also do a characterization where we quantify the contributions of the chosen impact for the product. So classification and characterization are two important steps in life cycle impact analysis. So while doing that, we also do normalization because we need to find what is the impact or what is the magnitude of these impact for different categories. So we need to normalize it, or we need to bring it to certain scale where we can know that because different elements will have different indicators or different aspects. So all these indicators will have to be taken, and finally we need to put out all these impact into a certain form so that we can analyze all, or we can compare all these different products easily. So for that we have a normalization, and then we have certain grouping where we sort and rank these indicators. Ranking, we mean which of the ones are more sensitive and which of the ones are less sensitive, and which of the ones is this particular product contributing maximum to. And then we have weighing, where we where we see what is important, or the aggregated results are weighed, and then we come to a final result in order to see what is the impact. So yeah, so classification, characterization, normalization, grouping, and weighing are different methods included in life cycle impact analysis. So coming back to our question, we have weighing. Yes, that is also important because that's how we finally uh, take all the attributes, we take the weights of all these attributes, and we finally come on to the overall impact. So weighing is important. Characterization is also part of it. Normalization is also part of it. Standardization, there is no term called standardization. uh, Sometimes probably so that option is given in order to confuse you. The term used is normalization. We normalize it. Standardization is not part of life cycle impact assessment, right? So the answer to this question is standardization. Yes, Raja has rightly put in the chat box. Yes, standardization uh, is not a step. So that's the answer. Let's proceed on to the next question. Match the following columns of stages of life cycle assessment with its description and choose the correct option. So different stages are given and different descriptions are given. So first one, completeness. B, sensitivity check, and C, consistency check. And the descriptions are: 1, ensure reliability of the final results and conclusions, effect of uncertainties in the data, allocation methods or calculation of contributions. And 2, assumptions, methods, and data are consistent with the goal and scope. And 3, ensure availability of relevant and complete information and data required. So let's go first one, completeness. So I think the answer is there in the description itself. So we can say that ensure availability and of relevant and complete information and data required. So we are talking about completeness. We need complete data, overall complete data. So we need to make sure that it's available and it's relevant. So that is completeness. Then sensitivity check. So by sensitivity, we mean that when there's some changes, uh, how is it affecting? Or if there's some uncertainty, is it affecting is that uncertainty affecting our uh, overall impact assessment? So, so the uncertainties in data, so the sensitivity due to this uncertainty in data, that is usually checked in the sensitivity check. So that is option one, where we ensure reliability of final results, the effect of uncertainty of data collection, allocation methods, calculation. All this is checked in this sensitivity check. And finally, consistency. So assumptions, methods, and data, we ensure that they are consistent with the goal and scope of the uh, analysis. So that works out to option B, A3, B1, and C2. Yes, so Raja has already put that in the chat box. Very good. Thank you. Okay, so let's proceed on to the next question. Which of is increase my screen, is it? Yeah. Am I not full screen in presentation mode? So you can see the slides on the side, is it? Uh, okay. How do I increase my screen? Can someone help me? Because I don't know how do I do that in Google Meet. Uh, does someone know how I can change the layout? Is it? Okay. To me, it's not. So, yeah, but how do I do that? Uh, okay, okay. Slide on one side and group on the other side. Yeah, that's how it is now, right? Okay, can I change the layout? Oh, change layout. Do I change it? Change layout. No, but if I change this, it wouldn't just change for me. Okay, let me just change it. Okay, I've changed the layout. Is there some change? Change layout. Let's say spotlight. Yeah, is this better? Or is there any change? Okay, so I think you'll have to change it at your end because now when I did it, my presentation screen is full and and yeah. Okay, yeah. So let me change back because so that I can see all of you also. Yeah. So I guess the previous one, probably the table, I could have increased the font size. The next presentation onwards, I'll ensure that the font size is a bit more bigger. Right. Let's proceed on. Question 11. Which of the following statement or statements are true according to Solid Waste Management Rules of 2016? Statement A, Pollution Control Board or Pollution Control Committee clearance is required for waste to energy plants less than 1 TPD. Statement B, all non-recyclable waste of calorific value less than 1500 kilocalorie per kg to be used for EC generation as RDF directly or indirectly or in co-processing in cement or thermal power plants. Statement C, 5% of fuel requirement for all industries within 100 kilometers of an RDF plant to be met by RDF. And statement D, RDF based power projects come under the purview of Electricity Act 2003. Okay, so Ilayaraja says B is the answer, which B is the answer, which means statement D and C are correct. Okay, so yeah, so that is the correct answer. Uh, because the first one, let's see then why are the other statements wrong. So statement A, pollution control board clearance is required for plants less than 1 TPD. How do we make that correct? Very good. Yeah, it should be greater. It should be greater than 5 TPD. So it's written less than 1 TPD, which means it's a wrong statement. It should be greater than 5 TPD. Now, statement B, all of calorific value less than 1500 kilocalories per kg to be used. How do we make that statement correct if that's a wrong statement? Anybody? Yeah, so it should be greater than 5,500 kilocalories. It's given less than 1,000 kilocalories. In order to generate fuel, we need more energy. So it should be greater. The yardstick is correct over here, like it's 1,500 only, but it should be greater than 1,500 kilocalories. So that's how we make that statement correct. And yeah, so this one, 5% of the fuel of all industries within 100 kilometers is to be used for the is to be provided by the RDF facility. So that is a correct statement. And D, RDF based power plants come under the purview of Electricity Act 2023. That is also a correct statement. So statement C and D are correct, which means option B is the correct answer. Right. Let's proceed on to the next question. Match the following processes of waste to energy conversion with its preferred feedstock and choose the correct option. So different processes are incineration, pyrolysis and anaerobic digestion, and feedstock is sorted organic waste, animal or human excreta, less suitable for high lignin waste, to unsorted waste, and three specific type of recyclable plastic. Okay, I'm sorry about the numbering. So this is A, B, C, and this is one, two, three. Yeah, now let's answer this. So first one, incineration. We've learned we are just burning it out, and yeah, so option B is the correct answer. Yes, I can see in the chat box it's already put as option B. Yes, option B is the correct answer because incineration we can use unsorted waste, and for pyrolysis we have discussed that we need a specific type of waste because this is a specific process which is used, and it's used at a very high temperature. So we need this specific type of recyclable plastic waste which is used in pyrolysis, and then anaerobic digestion we use sorted organic waste or animal excreta. Yeah. So option B is the correct answer. Very good. Let's proceed on to the next question. Which of the following, which of these statements is or are true about incineration? Statement A, the primary goal of an incinerator plant is to reduce landfill area requirement. Statement B, non-recyclable waste with low calorific value are preferred for incineration. Statement C, high calorific value of municipal solid waste in India makes it challenging to use it for incineration. Statement D, potential of energy generation by incinerator plant depends upon the composition of waste, density, moisture content, and inert material content. So first one, statement A, is that a right statement? So Shweta says D. Okay, Vinod also says D. So which means that is statement A and D are true. Okay, yeah. So let's see. Yeah, that is the correct answer. Statement A and D are true. So statement A is the correct statement. We reduce the landfill. Statement B, non-recyclable waste with low calorific value are preferred for incineration is a wrong statement. So what is the right statement? High calorific value. Yes, we just discussed that. We need high calorific value. So if that's the case, then statement C is again the same correction. High calorific value of municipal solid waste in India makes it challenging to use it for incineration. No, it makes it easier for using it for incineration. So yeah, so that's why this statement is wrong. Then statement D, yeah, potential of energy generation, it depends upon the characteristic of the waste which is incinerated. So yes, so this one, yeah, so statement D. So both statement A and D are correct, whereas others are low. Yeah, so this one we corrected by saying low calorific value, which makes it challenging for use in incineration. Yes, so I can see the answers are there in the chat box. So let's proceed on to the next question. Match the following stage of biomethanation process with its description and choose a correct option. So different stages: pre-treatment stage, anaerobic digestion, residue treatment, and the descriptions are: microbial activity takes place in the stage for hydrolysis, acidogenesis, and biomethanation of waste. Dewatering of sludge and aerobic curing takes place, and segregation or sorting of waste at source and shredding takes place in this stage. So 14th one, Shweta says C is the answer. Uh, okay, let's yeah, C is the correct answer. So let's see that. So pre-treatment is where we do all the segregation, sorting that we have already discussed. So yes, so that is 3. Now B, anaerobic digestion. So that also we have discussed. When it comes to biomethanation, it usually happens in 3 stages. We have hydrolysis, acidogenesis, and then we have biomethanation. So that is the anaerobic digestion. And then residue treatment, dewatering. So residue, whatever residue is left, we are doing that. So it is dewatering of sludge and aerobic curing takes place in this stage. Very good. I see in the chat box, C has been answered. Yeah, so C is the correct answer. Let's proceed on to the next question. Which of the following involves a biological process involved in waste to energy generation? This is a very easy question after answering so many questions. A, combustion of RDF, B, biomethanation, C, incineration, and D, co-processing of combustible waste fraction. Shweta says B, biomethanation. Yes, very good. That is the correct answer. We've discussed that biomethanation, it is in that process where we have a biological process involved. So uh, yeah, so it's not incineration, it is B, biomethanation. Incineration is just burning. So it's more of a chemical process than a biological process. Whereas in biomethanation, we have an anaerobic digestion, which is happening over there. Yeah, exactly. It is an thermal process which happens. Very good. So let's proceed on to the, yeah, so this is what we discussed. So we have ways to, yeah, biological process is biomethanation, and there are different thermal processes, which is RDF, incineration, co-processing, all that comes under the thermal process. Very good. Let's proceed on to the next question. Dash results in the production of biogas, partially digested sludge and hydrogen sulfide. A, incineration, B, biomethanation, C, pyrolysis, and D, gasification. Yeah, yes, it is biomethanation itself. We have discussed after biomethanation, what we get is product results in the, we have biogas, partially digested sludge, and then we have H2, hydrogen sulfide also. Yes, let's proceed on. Yeah, so this is what we discussed in the lecture. Whereas in the other process, we have discussed this already. So pyrolysis, we have an anaerobic environment, and we at a very high temperature. And in gasification, it's partial combustion with limited amount of air. So let's go to problem 17, which is match the following. So we have incineration, pyrolysis, and gasification, and we've been asked to match them. So we already discussed the answer to this very briefly right now. So you'll be able to answer this question very easily. So first one, information, it's a thermal method in an anaerobic environment. B, it's combustion of waste at a very high temperature in the presence of oxygen. And 3, it involves partial combustion with limited amount of air. So which does it work out to? A, yeah, option A. Because incineration, we know that it is 2, pyrolysis, we know that it is 1, and then gasification is, we just discussed the answer to this. So yes, so it is option A. Did I miss a question? No, yeah. Problem 18. Clean biogas refers to A, biogas with 95% of methane, carbon dioxide less than 5%, and no hydrogen sulfide. And B, biogas with 85% of methane, carbon dioxide less than 15%, and no hydrogen sulfide. And C, biogas with 95% of methane, carbon dioxide less than 5% and hydrogen sulfide less than 5%, and D, biogas with 85% of methane, carbon dioxide less than 15%, and hydrogen sulfide less than 5%. So yes, Shweta has rightly answered it. It is option A, biogas with 95% of methane, carbon dioxide less than 5%, and no hydrogen sulfide. So this is the composition that we get in clean biogas. Right, let's proceed on to the next question. So yeah, these are some technical details. If you can A or C, most probably A. Yeah, it is A. A is the correct answer. Now, problem 19. Optimum carbon to nitrogen ratio for adopting biomethanation process is 20 is to 30, 30 to 40, 40 is to 50, 10 is to 20. Yeah, it is 20 is to 30. We have discussed that it has to be 20 is to 30 in order to uh, do a biomethanation process. So yeah, these are some technical details which we follow. We'll have to remember that. Problem 20. Which of the following statements are true concerning composting and biomethanation? A. Composting is a process of controlled decomposition of organic waste, typically in aerobic conditions, while biomethanation involves decomposition in anaerobic conditions. B. Composting is a process of controlled decomposition of organic waste, typically in anaerobic conditions, while biomethanation involves decomposition in aerobic conditions. And C. Both involves decomposition in aerobic conditions, and D. Both involves decomposition in anaerobic conditions. So Shweta says D. Both involves decomposition in anaerobic conditions. Okay, so we are talking about composting and we are talking about biomethanation. So composting, we have discussed that it's decomposition of organic waste, and we need to provide it. There needs to be some air, so we provide air through certain pipes or tubes. That also we have discussed. So it is in aerobic conditions, whereas biomethanation is in anaerobic condition. So the first one is composting, where we are talking about aerobic conditions. Then biomethanation, it talks about anaerobic conditions, and it is involves decomposition, controlled decomposition of organic waste. So option A is the correct answer. Now both involves decomposition in anaerobic states is a wrong statement. I think some of you have posted D also as the answer, because composting happens in aerobic state. It is never in anaerobic state. So composting is in aerobic state and biomethanation is in anaerobic state. So only option A is the answer. If you recollect, we have discussed in last week's module that uh, when adequate amount of oxygen or air is not there, then it creates problem in composting, and because of this, we provide air. So we turn the after 4 to 5 days, we turn the waste out using some mechanical methods, or we upturn it so that adequate air can enter, and we also ensure that moisture doesn't clog the pores and then it doesn't allow air to enter. If such a case is there, we again have certain methods to eliminate that. We also provide air through certain pipes. So we discuss if this is a dust, if this is a pile which is kept, which is kept for composting, we have certain pipes which are usually put through which air is passed, and then we provide air. Yes, Shweta, yeah. So it is both are in, so one is in aerobic, one is in anaerobic condition. So option A is the correct answer. Problem 21. Dash is a fuel derived from combustible waste fractions such as plastic, wood pulp, or organic waste, except chlorinated materials, in pellets or fluff form through drying, shredding, dehydrating, and compacting of soil waste. RDF, yeah. So we have discussed this. We have discussed only one type of fuel, and also RDF's definition. We have discussed that in RDF we have it in the form of pellets, or we also have it in, so pellets are the 3D form, and then we also have these 2D forms also. So yes, so RDF is the right answer for this. Right, let's proceed on to the next question. All non-recyclable waste of calorific value dash to be used for energy generation as RDF directly or indirectly or in co-processing in cement or thermal power plants. A, greater than 1500 kilocalories per kg. Yeah, that is a very easy question because we've already discussed this one in the previous correct, which of the following was a correct statement question. We discussed that the calorific value has to be greater than 1500 kilocalories per kg. So Yeah, let's go to the next question. The given schematic diagram represents what? A. Pelletization. B. Biomethanation. C. Composting. D. Pyrolysis. So let's look. So at the diagram, so we have raw garbage. Then we have a pre-segmentation, shredding, hot drying. So we have a hot generator. From that air is coming. Secondary shredding, air classification. Yeah, here comes the key. Now we have RDF coming over here. And then, so from this, something is coming from the bento additives, and then we are storing it. So now what does this represent? So Shweta says A, pelletization. Yes, very good. It is pelletization because this is the process of making RDF, and we are storing it in the form of pellets in this diagram. The other options, yeah, this is not biomethanation, composting, or pyrolysis. So yeah, so it is option A, pelletization. Now let's proceed on to the next question. Which of the following characteristics determines the suitability of RDF for co-processing in cement plants? A. Moisture less than 20%. B. Calorific value greater than 3000 kilocalories per kg. And S. Sulfur less than 2%. And D. Free from PVC, explosives, batteries, aerosol containers, biomedical waste, etc. Okay, so A, B, and C is what Shweta says. So which means D, free from PVC, explosives, batteries, aerosol containers, biomedical waste. Is that not a requirement for co-processing in cement plants? B is wrong for sure. Okay, B is wrong for sure. Are you talking about this B or are you talking about this B? I think this B, calorific value preferably greater than 3000 kilocalories is wrong. Okay. No, so actually it's all of them. It should have a moisture content less than, so we are talking about the suitability of RDF for co-processing. So it should have a moisture content less than 20 percentage, and the calorific value can be, it's preferably greater than 3000, and the sulfur percentage should be less than 2 percentage, and it should be free. So it's A, B, C, and D. It talks about calorific value greater than 1500. Uh, no, if it is greater than 3000 also, we can use it in co-processing of in cement plants. Okay, so all of them, the answer is all of them. Now this one, okay, if you're really sure, then I might have to check the slides again. To my knowledge, if it is greater than 3000, it can be used. So all of them, and again, we don't have an option where B is not there. So going by that logic again, it has to be all of them. I can probably check this. Okay, I'll just, I forgot to put the slide over here in this presentation. So that part also I can, the difference is due to the word suitability. Yeah, we are talking about suitability, whether it's, so if there's any condition which is being violated, then we are saying that it is not suitable. So it's the same. Yeah, if it is not, if there's something which cannot be possible, then it's not suitable. But here, all of these are the conditions. Under these conditions, yeah, it is suitable. Yeah, so if you have something greater than 1500, then if the calorific value is greater than 3000, then it is again suitable, right? So if 1500 was given as the metric in the slides, then again that is suitable, right? Let's proceed on to question 25. Dash results in the production of ash, flue gas, and heat. Okay. A. Incineration. B. Biomethanation. C. Pyrolysis. D. Gasification. D. Gasification. Okay. Anybody? Any other? Gasification we discussed. We get syngas out of. Do we get syngas? Yeah, we get syn pyrolysis. Gasification also we get. No, we do not get no, sorry. Yeah, pyrolysis we get syngas. But then in this one, just production of ash and heat is mainly associated with incineration. In pyrolysis, no. It's in, we do not. We have more components coming out of pyrolysis. It's not just these. So the answer here is incineration. And biomethanation, we know that it's we learned different as different elements which are coming out of Uh, yeah, syngases and pyrolysis, correct. And gasification, no, gasification, what were the things coming out of gasification? There are more constituents coming. I'm not being able to, but there are more constituents coming out of gasification. It's not just these three. Uh, Incineration is the most easiest thing where you get ash and heat and some gas out of it. So, yeah, incineration is the answer to this one. Problem 26. Which of the following statements are true concerning incineration? A. Incineration cannot deal with hazardous waste. B. Pre-treatment of mixed waste is necessary. And C. The preferred waste fraction is segregated non-recyclable waste of high calorific value. D. It is an anaerobic process. So this is multiple correct answers. So they've asked which of the following is true. So first one, option A, incineration cannot deal with hazardous waste. Can it deal with hazardous waste? It can deal with hazardous waste. So we have learned about different. It can. It hazardous waste can also be incinerated. So this is not a correct statement. B. Pre-treatment of mixed waste is necessary. Yes, that is a correct statement. We need to do some pre-treatment if it is a mixed waste. And C, the preferred waste fraction is segregated non-recyclable waste of high calorific value. Yes, that also we discussed. And D, it is an anaerobic process. So it is an aerobic process. So B and C are the correct answers over here. Right. Let's go to the next question. The given schematic represents which of the following? A. Pelletization, B. Biomethanation, C. Incineration, and D. Pyrolysis. So let's look. So we have a fee. Yeah. So we have the delivery happening over here, and then that's so we have a feed hopper, and then it goes this way, and then it's slowly entering. The combustion of solids are happening over here. Slag is removed. Combustion of volatiles are happening over here. So we have certain boilers in this region. Then we have so this is a controlled room. Again, this is a keyword. So this is a controlled room which is there. And then we have flue gas, drying, cleaning. So yeah, flue gas. So flue gas, that's again another term, flue gas. Then we have chimneys. Right. So yes, LA Raja says incineration. Okay. Anybody, any other answers? Yeah. So the answer is right. It is incineration because we see the process, it's coming and there's not yeah, you're just heating it. Combustion of volatiles in it's or solids both are being heated over here, and then whatever is coming out of it, flue gas and drying and cleaning. So this is the schematic showing incineration. The other pelletization, we already discussed the flow chart. Biomethanation, we know. Pyrolysis also we know. It needs to be at a very high temperature. So yeah, so let's go to the next question. Dash consists of methane, carbon dioxide, hydrocarbons, hydrogen, and carbon monoxide. RDF, clean biogas, syngas, and flue gas. C, yeah, syngas, very good. Again, yeah, this we've seen in the lecture that syngas composed of all these elements. So there's nothing much to explain in this. This is a composition of syngas. It's given directly. Choose the correct sequence corresponding to air pollution cost. A, RDF, so it's a correct sequence, so which means in descending order. Okay, ascending it's given mixed. So RDF produces more compared to gasification compared to composting. Then RDF produces less than gasification, which is lesser than composting. And C, gasification produces more than RDF, which is more than composting. And degasification produces lesser than RDF, and that is lesser than composting. So we are talking about pollution. Any guesses? Okay, let's see which produces the maximum pollution. RDF produces the maximum pollution actually, because in the whole process that's involved, there is more pollution which is caused. So yeah, RDF produce, so RDF comes the maximum pollution. among all these. Gasification and composting are the different. And we also know that composting gives the minimum, because we we're not doing anything. We're just putting it for composting, and we're not burning, or we're not emitting any harmful gases or any greenhouse gases. Then comes in between comes our gasification. So option A, RDF, gasification and composting is the correct sequence. Right. Let's proceed on to the next question. Choose a correct sequence corresponding to volume reduction of waste. And so the option goes as pyrolysis reduces more volume compared to anaerobic digestion, which reduces more volume compared to composting. B, composting reduces more volume compared to pyrolysis, which reduces more volume compared to anaerobic digestion. And C, anaerobic digestion reduces maximum volume compared to pyrolysis compared to uh, composting. And D, pyrolysis reduces maximum volume compared to composting. And then last is anaerobic digestion. So Shweta is confused between A and D. But one thing we know that composting will have the maximum volume, right? Because you're not reducing anything over there. You're not converting anything. You're just keeping it in the compost pits. Probably you're compressing it a bit after some time, but it will definitely have maximum amount of volume. So composting comes last. That is for sure. Composting comes last. And then we have pyrolysis and anaerobic digestion. So again, if you look at that pyrolysis, you're again heating it up, or there's some amount of burning which is involved over there. So that reduces the maximum amount of volume, because you're again maximum amount of volume. In anaerobic digestion, biomethanation, we saw that there are several elements which are produced after that. So that comes the next. So it's pyrolysis, then anaerobic combustion, and then digestion, and then composting. So option A. Yes, Shweta and Elera ji, yeah, both you're right. It is pyrolysis followed by anaerobic digestion, and then comes composting. Yeah, so this is what we learned in the module. So from this only, all this is these two questions which were there before. So if you look at what are the volume of reduction. So we saw that in pyrolysis, incineration, pyrolysis, gasification, and RDF, it's about 75 to 90 percentage. Composting, it's only 15 to 30 percentage, and anaerobic digestion, it is 45 to 50 percentage. So it is from this data that question was made. So that question was a bit tricky. It was asked in a different way. So from this data is where we are getting that. And yeah. What was the other question? We had one more, right? Yeah, air pollution cost. Yeah, pollution. Yeah. So in this one, pollution cost also, it's given over here. Pyrolysis have got maximum pollution, gasification medium. RDF again has maximum pollution, whereas composting is minimum pollution. So these two questions were asked from this table, which is there in this paper. So we've discussed this in our lecture. So these questions came from this table. Right. So let's proceed on to the next question, which is, yeah, next question. Match the following. So we have already discussed this. I think like we can just skip this question. Uh, or very quickly we can answer. Deposits are which cannot be renewed. Funds are which are renewable. Flows are which cannot be depleted. Yeah. So let's proceed on. Yeah, option A is the answer for this. Now, this one also we have discussed briefly. This is the last question, so let's try to attempt this. Normalization, grouping, and weighing, and then what is the information it's given. So include sorting and possible ranking of indicators, relates to magnitude of impacts in different categories to reference values, and three, aggregating results across impact categories resulting in single result. So yes, so normalization. What's the answer? Normalization relates to magnitude of different impacts in different categories to reference values. So we are converting everything to these reference values. Then grouping, it involves sorting, possibly ranking of indicators. And then we have weighing, which is aggregating results across impact categories, resulting in a single result. So that works again out to option A. Right. So that's all for, yeah, that's all for today's discussion. If you have any doubts in any of the questions that we discussed now or anything in this lecture, you can ask now. No doubts? Okay. I guess exam related queries, most of you have already asked in the previous classes itself, so maybe that also might not be there. Anything? Any doubts anywhere? Nothing. Okay. Good. So yeah, so we finished the 2 hour class in 1 hour. Actually, this there is nothing there are not lot of numericals in this course, right? So we will finish the discussion very fast. So it's good. So if that's it, we can end today's discussion. So thank you all for joining, and thank you Shweta and Ele Raja for being very interactive, putting all the answers in the chat box and also speaking out when uh, speaking out. So thank you so much. Thank you very much, ma'am. Yeah. So okay, so thank you. So have a good night and see you all next week with module nine's questions and discussions. Bye bye.